Question 35 is part of this bigger word problem from 35 to 37, which says that the Smith family is planning to build a 3-room cabin which consists of 2 bedrooms, BR, and 1 living room, LR. Shown below are the rectangular floor plan, left figure, and a side view of the cabin, right figure. In the side view, the roof forms an isosceles triangle, triangle ABC. The walls are perpendicular to the level floor, ED, and then AC is parallel to ED. F is the midpoint of side AC, and BF is perpendicular to AC. And we're given these 2 figures, and then we're told at the bottom, during the week the Smiths plan to roof the cabin, there is a 20% chance of rain each day. And then question 35 says that Mr. Smith plans to build a 3-foot wide walkway around the outside of the cabin, as shown in the floor plan. What will be the area in square feet of the top surface of the walkway? As answer choices, we have 3-digit numbers ranging from 171 to 720. And the only other relationship that I'm seeing is that E is the double of C. All right, to start off here, I would just point out that when we get to these types of questions on the ACT that have multiple sub-questions, and these always come up on the math section, it's very common for the ACT to basically throw a ton of information at us. And a large part of navigating through these questions is just figuring out what is actually relevant in the given information. So going back to 35, they were saying that Mr. Smith is planning to build this walkway around the outside of the cabin as shown in the floor plan, and the floor plan is right here. So they're referring to this shaded part right around the cabin, and they're asking for the area of the top surface of that walkway. So as far as the ACT math concepts for this particular question, it looks like we're going to be dealing with this idea of an area of a shaded region, which is a concept that comes up every once in a while, as well as more generally the areas of rectangles. So I'm going to write out the approaches that we can take on this question, and they're both more formal. So approaches, formal, and they are find the area of the walkway by either 1, subtracting the rectangle areas, or 2, by basically finding it piece by piece, the area of this walkway. And I'm going to just move this by over here. Okay. Let's look at this first way of doing it, which is to subtract the rectangle areas. And basically what this comes down to is noticing that we have essentially 2 rectangles involved here. We have this larger rectangle, the 36 by 30 foot rectangle, and then we also have this smaller rectangle inside of it, which has the dimension 24 by 30. And so what we can realize is that if we get the area of the larger one and then subtract the area of the smaller one, what we'll be left over with is the area of the shaded part, which corresponds to the area of the walkway. So that would give us our answer that we're looking for. So let's go ahead and do that calculation. The area of the larger rectangle is going to be 36 by 30. So I'll write that out right here, 36 by 30. And then we're going to subtract from that the area of the smaller one, which is 24 by 30. 24 by 30. And I'm also just going to, at this point, double check that I looked at those correctly. 36 by 30 is the larger one, and then 24 by 30 is the smaller one. Yeah. And the reason I was doing that is because there are a lot of opportunities here to just mix up these numbers, especially because like the 30 here is also the length of 30 here. And I know that the ACT loves to give me opportunities to mix things up. And that's the type of attention to detail and double checking that we want to basically be doing throughout any question that we're solving. So anyway, we know that this looks good. Let's go ahead and put that into the calculator. 36 by 30 gives us the larger rectangle area, which is 1,080, minus 24 times 30 in parentheses. And that's going to be 360 in total. So this is 360, which, as we said before, is going to correspond to the area of the shaded region, which is what we want. So our answer is C. Let's now look at this other way of finding the area of the shaded region, which we said was to split it up into pieces. And there are several different ways we could cut this thing up. It's arbitrary. I'll just cut it up like this. So extending this line and extending this line extending this line and this line. And let's start out by finding the area of this longer piece right here. We know that it's 36 feet long, and we also know that the width of the walkway is 3. So this is going to be 36 by 3 right there. So I'll write that out. And then it's also going to be the same thing over here. This side is also 36, just like from here to here. And it also has a width of 3. So basically we have 2 of those. I'm just going to multiply that by 2. And then we have these smaller little pieces left over, each of which is 24 feet by, again, the width of 3 feet for the walkway. I'm going to add that, 2 times 24 times 3. And this should give us the same area that we got earlier. Let's check it out on our calculator. So we have 2, in parentheses, 36 times 3, plus 2 times 24 times 3. And then that gives us 360 like we expected. And so that would be the other way of solving this question. All right, I'm going to clear this out and let's go over the wrong answers to see the sorts of mistakes that they were predicting we'd make here. Answer choice A of 171 could reflect a mistake in trying to do it this first way of subtracting the rectangle areas. For example, we saw that the original equation was this, and that the dimensions of the larger rectangle were 36 by 30. But if someone were looking at the smaller rectangle and added the 3-foot walkway only once to try to get the dimensions of the larger rectangle, they could have done 30 plus 3, which would be 33. And then 24 plus 3, which is 27. So essentially they're forgetting to add 3 twice to get that larger dimension. So it'd be 33 times 27, and then they subtracted correctly the area of the smaller rectangle, which is 24 by 30. So we'll see what that gives us on our calculator. 33 times 27 minus 24 times 30. Yeah, and that gives us 171, so that could reflect that mistake. Answer choice B of 324 could reflect a mistake in trying to do it this piece by piece way, because if we were to cut this up like this into these smaller pieces, as well as like a smaller piece over here and here, and I'm not going to do this on the calculator just because it'll take some time, but if we had done 24 by 3 to get this area, and then multiplied that by 2 to add it to this little area over here, and we'd also done 30 by 3 to get this area, and multiplied that by 2 to get this area, and we'd added all those up together, that would give 324. And the problem there is that that forgets to add these corner pieces, which when added would give us the correct answer of 360. And then answer choice D, I'm not sure what they were expecting with that answer. It's probably another example of some miscalculation here in these dimensions. And then answer choice E of 720, that reflects just the total area of the cabin. So if we did 24 by 30, that's going to give us 720. 24 by 30, yep, 720. All right, and then let's think about what did we ultimately need to know on this one. I'll write this out. Needed to know, and really we saw that in either of these situations, it came down to areas of rectangles. So I'll write that out, area of rectangle. And then if we had done it this first way of subtracting the rectangle areas, that also comes down to this conceptual understanding that is tested every once in a while in the ACT, that when we have some shape, for example, we'll just make another rectangle, and let's say there's like a circle inside, and they ask for the area of the shaded region, that one way to get that shaded region is to find the area of the bigger shape, and then find the area of the shape inside of it that's not shaded, and then just subtract it to. And then whatever's left over is going to be the shaded part. So that is also sort of being tested here. As far as ultimate takeaways on this question, as we saw mathematically, ultimately it was pretty basic in terms of areas of rectangles, but that the answers were very detail-oriented and predicted small mistakes in our calculations, especially this thing about adding 3 only once to one of these sides as opposed to twice. That's an easy mistake to make, and they have an answer just waiting there for that. The other big takeaway from this question is just noticing what information we ultimately needed to use from all the information that they threw at us. And it really came down to looking at this figure and seeing the dimensions. And that was really it. We didn't need to use this other figure. We didn't need to use most of this information in the word problem. So it's helpful to keep that perspective in mind when we get to questions that are very wordy like this, that a lot of times it's more of a matter of figuring out what information is actually relevant to the question. And for more on that, check out the video that I've made that summarizes 35 through 37, because as it turns out, we literally don't have to use any of this information, including this, for any question from 35 to 37, and we'll talk a little bit more about why that is. So with all that said, let's go on to question 36.